Here we're going to be doing the ramps and blocks example problem from the notes. So we have a frictionless car, no force of friction, and the whole system is going to be accelerating. We're going to find out what that acceleration is and the tension in the string. First step, as always, is drawing the picture. So I've got my 1 kilogram block on the ramp, my 0.6 kilogram block hanging from the side. Step 2 is finding my directions. I'm going to say if the system moves clockwise, it's in the positive direction, and counterclockwise, it's in the negative direction. From here, just like the at-wood machine problem, we have to do an equation for each block. Since for this block is going up or down the ramp, we're going to just do the x direction, and this block can only move up or down, so that's the only direction we're worried about. I'm going to call the hanging block block 1 and the block on the ramp block 2. So for the hanging block, my forces, I would have tension positive and force of gravity 1 negative. So that's going to equal m1 times acceleration. For block 2, I would have force of gravity parallel in my positive direction and tension in the negative direction. That's going to equal m2 times acceleration. Just like the at-wood machine problem, we can add these together. Since we've done that one before, I'm going to skip writing down everything and just make you realize that the t plus minus t makes those cancel out. And what we are left with is force of gravity parallel minus force of gravity 1 that's going to equal m1a plus m2a. To solve for a, we have to factor it out. So my left side remains force of gravity parallel minus force of gravity 1. Factor out the a. I have m1 plus m2 left over. Finally, I divide by my masses. Do that up here. Top right, force of gravity parallel minus force of gravity 1. And that's going to be divided by m1 plus m2 equals a. Force of gravity parallel is the sine of my angle, which is 32 degrees, times the mass of the block, which is 1 kilogram, times 9.8 meters per second squared, minus force of gravity 1, which is 0.6 kilograms times 9.8 meters per second squared, all divided by mass 1, which is 0.6 kilograms, plus mass 2, which is 1 kilogram. Plugging into our equation, we would get acceleration is negative 0.43 meters per second squared. That tells me that the system is going to go in the counterclockwise direction. That's the way it's going to accelerate. To solve for tension, I can plug back into either one of these equations, and I can solve for t. And if I do that, you should find that your tension is 5.6 newtons. Just have to plug your A back in to either this tension or this tension to solve. And that's blocks and ramps.